Hello, Professor. Hello, everyone. We are Group 52, and today we will present about the artificial intelligence for noise detection in ventilation fan models. About the agenda, we have four parts. First is the team introduction, and next team selection. Next is the formulation of measures and AI models definition. And the last is the future work. First is the team introduction. My group have two members. My name is Bu Lei. I am team leader and my major is industrial engineering and management. The main task is selection, problem identification, formulation of measures, report making, review and challenges. My team members is Nguyễn Việt Hoàng. His major is computer science and main task is the formulation of measures, report making, AI models definition, and the confirmation of effectiveness. About the background of the project, I will present about the importance of the air. So the substance people take into their bodies the most in a single day is air compared to food and drink. It is about 14 to 15 times greater and more than 80% of what person takes in over their lifetime is air. Improving air quality is an essential factor in creating an environment for healthy living. So people spend long hours indoor and take large amounts of air into their bodies. So yet invisible pollutants breathe around inside in addition. So we think the air coming from the outside contains various kinds of impurities. So by ventilating, removing polluted air and bringing in fresh, clean air, you can create a healthy living environment for both people and their homes. So next, we will talk about the ideal ventilation method. Ventilation is the process of bringing the clean air in from outdoors and exhausting polluted air generated indoors to the outside. Indoors, various air pollutants are produced, including substances emitted from building materials and furniture, tobacco smoke, cooking odors, dust, and moisture. Human activities such as moving around and opening or closing windows also generates air pollution in different daily situations. So, additionally, we concern such as sick building syndrome caused by chemicals from building material and furniture mean that polluted indoor air can negatively affect health. So that is why every home should have at least one ventilation fan, especially in rooms that use the air conditioning. To understand about how does the noise affect the ventilation fans, let's look at a simple example of how the noise affects user. On the left, we see the noise ventilation fan. Even though it provides fresh air and creates a comfortable environment, the noise level is too high. So as a result, user cannot sleep well. So this shows that the noise directly affects comfort and customer satisfaction. And on the side, we see the ideal case. The fan still provides fresh air and comfort, but the noise is either very low or almost silent. So this allows the user to sleep peacefully and feel comfortable throughout the night. And this symbol demonstrates why controlling the noise is so important. A quiet motor doesn't just improve product quality and it significantly uh, enhance the user experience. And in the ventilation fans, the noise mainly comes from the motor. That is why the team chose the topic related to the motor noise in ventilation fans. But why is it necessary to apply the AI and how can it be applied? Let's explore together. Right now, most model noise inspection are still performed manually by humans, so workers listen directly to the model and try to judge whether the sound is normal or abnormal. In the past, as my company, an operator listened closely to the model to detect the unusual noise. Although this method is simple, so it depends completely on human hearing and experience. However, this approach has several major weaknesses. Like high subjectivity, different people may judge the same sound differently, and difficulty in precise measurements. Humans cannot quantify sound or vibration level. Next is the susceptibility to fatigue. After listening for a long time, concentration drops, increasing the chance of mistake. Not suitable for large-scale inspection. Human inspection is slow and cannot efficiently handle high production volumes. Difficulty in storing and analyzing long-term data, since there is no digital record. So it is impossible to trace past condition or analyzing the trends. And then the last is the high risk of leaking energy products to the next process or to the market. Human error can cause a defective motor to pass inspection and leading the quality issues later. In short, under human space, noise inspection is common today, so it has many limitations. The quickness shall show why adopting automated and AI-based inspection method is becoming increasingly important. So this is a countermeasure model sound inspection by AI. First, this technology detects abnormal motor sound, more specifically abnormal vibration that humans may not easily notice. Using AI allows us to evaluate motor quality more consistently. Let's begin with the hardware session. So, accelerometer are attached to to the device to measure vibration generated during the operation. These vibration signals are then passed through an amplifier and IEDE converter, and finally sent to a computer. The system converts the raw vibration data into a spectrogram, which is basically a visual representation of a vibration patterns over time. And this spectrogram allows us to clearly see any irregularity in the model behavior. Next, with the software components, the AI model analyzes the spectrogram to evaluate irregularity in the vibration patterns, vibration strength, stabilities, typical pattern associated with the chemical issues. Based on this analysis, the AI determines whether the model is okay or NG. On the left, you can see example of the OK models. These big spectrograms show consistent and stable patterns. On the right, the NG example contain price, uneven or distorted areas, indicating abnormal vibration caused by issues such as misalignment, where our assembly defects. In summary, by combining precise sensor with AI-based vibration analysis, this system can detect motor defects quickly, improve accuracy, and reduce the dependence on the human inspection, and enhancing quality control in smart production environments, and represents a significant advancement in automatic motor inspection. Imagine you are trying to spot a tiny scratch on a camera lens. If you take a photo but apply a heavy blur filter to it, that scratch disappears. You can no longer see it. Exactly what happened with traditional AI in assertive maintenance. Currently, the standard for detecting files without labeled data is the denoising autoencoder DAE. As you can see in the picture, this model works by compressing sound into a tiny bottleneck to remove the background noise and then expanding the backout. However, we discovered a fatal flaw in this approach, which we call oversmoothing. In the real world, a loose wire in the ventilation fan creates a micro interruption, a silence that lasts less than 30 milliseconds because traditional autoencoder compress data so aggressively. They treat this tiny gap as noise and uh, essentially Photoshop it out. They fill in the gap, making the broken motor look healthy. The consequence, the error signature is eraser. During the reconstruction, the AI tells us the motor is fine right until the moment it fails. To solve this disappear file problem, we look outside the field of aesthetics. We found our answer in biomedical imaging, specifically the unique architecture. Originally, UNIC was designed to segment tiny tumors in MRI scans of the human brain. So why does this fix out the problem? Just like a doctor needs to see the sharp edge of a tumor without blurring, we need to see the sharp edge of a signal gap without the smoothing. So you will notice this architecture look like the letter U. So the key innovation here is these horizontal arrows called skip connections. Think of the bottleneck at the bottom as a summary of a book, so it captures the big picture, and this skip connection as direct photocopies of specific page. These skip connections are like teleportation tunnels. They take the high resolution detail from the start and teleport them direct to the end. Bypassing the compression, this turns the task from simple denoising into the structural reconstruction. Action: we give the point to the attention gatebox. However, the factory isn't a quiet hospital room, so if we just copy everything, we copy the noise too. So we added the attention gate. Think of these as cognitive filters, just like how you can focus on my voice while ignoring human of the air conditioner. This gate learned to block out random factory noise while letting the rhythmic harmonic pattern of the motor pass through. So this medical inspired approach work for motors. The data say yes. On the top left, you see our analysis. The blue and red dotted line represent traditional models as the background noise gets louder. And moving right, the accuracy crash. Our model, the green line, maintains high accuracy even in the noisy environment. But our most critical discovery in the crappy regarding our physics informed data strategy. In most AI simulation, a sound wave is felt as a perfect thin line, but in the real world, motor vibrate. This vibration causes the sound frequency to the world global silently, a phenomenon known as the Doppler effect. If we train the AI on the perfect thin lines, it gets confused by the real wolfly lines, and we introduce thick line uh, augmentation, essentially teaching the AI that fuzziness is normal. This single chain improved our robustness by 19%. It proved that understanding the physics of the machine is just as important as the computer code. Finally, we concluded as we conducted a stress test to find the physical limit. For found longer than 130 ms, we achieved 100% accuracy. However, at 30 ms, accuracy dropped to 77%. This is not a software bug, but a resolution limit. At 30 ms, the file is smaller than a single pixel on our spectrogram image. We have effectively found the atomic limit to what this central system can see. What is the future work? Uh, Currently, AI just decided which is OK or NG products, cannot judge which points of the model E NG, so the next research is research date and modify AI system to determine the NG type of models. So that's all for the presentation. Thank you for listening.